5A notes rate of change in slope, which is on page 2. If two measures are related, the rate of change between them is called the slope. The formula for calculating the slope of a line segment passing through 2 points, and we're going to call them x with a sub 1 and then y with a sub 1, and here's the x sub 2, y sub 2. We're going to have 2 points, and we have to have some way to differentiate between the two of them, because if they were both x, y, they would look exactly the same. So this means the first point, the x of the first point, and the y of the first point. The slope is going to be equal to, we always use the variable m for slope, rise over run. So what does that mean? If I come over here and I'm looking at this line AB, the run is going to be the change in the x values. So A, I'm going to move right 1, 2, 3, 4, 5. So for this, the run is equal to 3. Then the rise is going to be the vertical move from the y value here to the y value of B, and you can see it's going up 2. So the rise is equal to 2. So we'll say over here that AB has a slope. If I'm going to do rise over run, my run was 3 and my rise was 2, so 2/3. Notice that we rewrite this a little bit differently here. Sometimes you will see the notation written this way. This delta y, that's a Greek letter, means the change in the y value. So the rise is a change in the y values over the run, which is the change in the x values. And another way to write that is a formula where I subtract the 2 different y values and put it over and subtract the 2 different x values. CD, for our graph, we're going to look at its slope. So we're going to first do the run. And so for the run, we're going to go negative direction. So to the left is negative. So we're going to go left 1, 2. So a -2. And then from here, we're going to move up 1, 2, 3, 4. So the rise is 4. Run is -2. Rise is 4. So when I write that, CD has a slope of 4. So the rise is 4 and the run was -2. So that's +4. It's an ugly 4, isn't it? +4 over -2, which is going to simplify to -2. So the Greek letter delta represents the change in a variable. In example 1, we want to classify the rate of change for each graph as either positive, negative, 0, or undefined. So it's helpful to be able just to look and think about what the slope might be without any numbers involved. So for A, you can see as our run changes, so as I move over for X, the rise remains the same, so it's unchanged. So there is no change in our y value. So our slope is going to be 0 because there's no change. For B, as x increases, y increases. So as it increases, that means it's going to have a positive slope. For C, as x increases, y gets smaller. So because it gets smaller, we're going to say that it has a negative slope. So notice that as you go from left to right across the page, the positive slope rises. And as we go from left to right across the page, the negative slope falls. And for the last one, we look and we see that for every x, we have all kinds of different y values, which doesn't make any sense. So we're going to say that it is an undefined slope because x never changes, but yet the y continues to change. So that is an undefined slope. Example 2 says find the slope of the line through 5, 2, and 7, 8. Now we have a couple of choices on way to do this, and one of them would be to plot the 2 points. So we have 5, 2, and 7, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. So we have our 2 points that connect to make a line. So I'm going to sketch those. And I want to figure out what the rise over run is. So to go from the first point to the second, I'm going to go right 2. So my run is 2. So I'm going to put run is equal to 2. And my rise, I'm going to go up 1, 2, 3, 4, 5, 6 is 6. So rise over run is 6 over 2, which simplifies to be 3.